I've got about 3 examples I'm going to look at to help you with this first derivative test and graphs and how to put the information on the sign diagram that I want. So let's get going. We're going to be finding the derivative of a curve to help us find where the curve is increasing, where the tangent line's positive, decreasing, where the tangent line's negative, or at its max and or min value, and that's where my tangent lines are going to be 0. The quickest way to accomplish this: find and graph the derivative. Second thing, find where it crosses the x-axis, that's the zeros, or where it doesn't exist. These are called critical values or partition numbers. You draw a number line. Indicate on the number line all the information from the first step, and then indicate the sign of y prime from the graph. If the curve is above the x-axis, it's positive, and if it's below the x-axis, it is negative. So I've got this particular function. First thing I want you to do is go find the derivative. This is my first step. So pause me, you go ahead and find the derivative, and then unpause me. I'm going to keep on going. So if I get my derivative, 4 times negative 1/2 would be a negative 2x to the third plus 9x squared plus 38x minus 120, and the derivative of a constant is 0. So now I need you to go graph that. So let me get my calculator. I've already typed it in. Let me do zoom 6. Watch it as it graphs. Well, Pooh Bear, I didn't turn mine on. Okay, now I'll ask it to graph. It came down, it hit here, here, and here. So it looks like the picture I've got right here. I've got about 3 zeros. So now that's my next job. I got to go find where the derivative crosses the x-axis. That's my zeros. This one is not broken, so I don't have any discontinuity in this particular problem. A couple of other examples, I will have that. So second, trace for the calc menu. Let me do 0. I'm going to go find that one. Negative 1, 2, negative 3. Looks like negative 4. You know, it could be negative 3.98. I can't tell. So I'm going to type in negative 5. And it erects a little barrier. Let me type in negative 3. And that'll be the barrier on the other side. I do not guess. And I should have the word 0, and it in fact is negative 4. Go try to find the other two. I'm going to see if that's what I've got under my little yellow box here in just a second. 0, type 2, 4. So 2.5, that's my second one. So it looks like negative 4, 2.5, and 6. So let's see. Negative 4, 2.5, and 6. Okay. Third and fourth step. Third, it says draw a number line. That's not too bad. Up top, I need you to indicate f prime or y prime, because this is where we put information about the derivative. And below, this is about my x values. So I know that my derivative is 0 at, I'm going to have negative 4, 5/2, and 6. Let's see if that's what I've got there. Very good. Now, here comes the signs. So indicate the sign of y prime from the graph. Okay, now on negative 4, here's negative 4 right here. This is above, so this should be positive. Between negative 4 and 2.5, my derivative is below, so this should be negative. Between 2.5 and 6, it's above, it's positive. After 6, it's below, it is negative. Now from here, I can tell you where the original curve, and guys, we haven't even graphed the original curve, but I can tell you where it's increasing, where it's decreasing. It's going to be increasing on all these sections that have positive. So from negative infinity to negative 4, and then 2.5 to 6. Okay? And it's decreasing on all the negative sections. So from -4 to 2.5 and 6 to infinity. Fairly quick. And I haven't even looked at the original yet. Another thing I'll be doing here eventually, I need you to start thinking about this. This is going up. The original part's going up here. It's increasing. It's leveling. And it's coming down. I'm going to have a maximum at x equals -4. My curve is coming down, leveling, going up. There's going to be a minimum here. It goes up, levels, comes down. I'm going to have a max at x equals 6. That's something else I'm going to be exploring here later, excuse me. Okay, example 2. I've got this function. I need you to rewrite it. See if you remember how to do it. It should be x raised to the 3/5. Go find the derivative. So that'd be 3/5 x to the -2/5. Some people like to see this because here at this particular point I know x equals 0. I'm going to have an issue here. If you graph your derivative, it should look like this, and it looks like I've gone decimal window because some of these are real close to the axis and you can't tell a lot of information. So why don't you graph that and then do a zoom decimal, which is zoom 4, and see if you get a picture like this. Now I do have an issue at x equals 0. It's not defined here. It is legal here. Alright, so notice x cannot equal 0, but it is part of the domain of the original. This is called a critical number. So here's my number line, f prime on top, x on the bottom. The x that I am concerned with right now is 0, and it's not defined. Now if you'll notice on either side, my derivative is above, so that means my derivative is positive for these. The original curve is increasing on the interval. Remember that 0 does not, or 0 did exist in the original, so it's part of it. So if you graph the original, you'll notice that it increases on its whole domain as it goes up. Let's see, I've got one more example where we have to use the quotient rule. So indicate who u is and who v is. And your u prime, v prime, see if that's okay. Got a lot of little boxes here. Rewrite your quotient rule over here and plop them in where they need to go and see if you come up with what I've got. Always start bottom, v squared, then you got v times u prime minus u times v prime. So at this point in time when you use the formula, remember that's it for the calculus. Right now it's all algebra. So distribute through, start cleaning up. Those eliminate. Looks like I end up with 6x over that. Okay. So we graph that. I need you to graph that. So let me go get my graph. Whoopsie. Clear that out. So guys, I need parentheses around the numerator because that is just not a single letter or single number. I have to tell the calculator that whole thing's up in the numerator. X squared minus 1. That quantity squared. So we'll do zoom 6. Let's see what happens. I've got breaks. Remember, right here, my denominator, it cannot be 0 at -1 and 1. So that's why I actually have some physical breaks here. It does have a 0 right here at the origin, because if I put 0 in this particular problem, I end up with 0 over -1 squared. 0 over 1 is 0. So 0 is a legal number. So that is my picture of my derivative. So let's see what I've got under this. I'm going to get my picture back up. It says, notice in the derivative that x equals 0 for f prime of x equals 0. but x cannot equal positive or negative 1, either in the original or the derivative. This is an example of partition numbers. But regardless whether I don't care if you know if they're critical or partition, I really don't. They both have to be put on the number line in order to pull off the correct information. So if the derivative is equal to 0 or it doesn't exist, it's going on the number line. So let me see, what else have I got? Keep on going. Alright, so that should be negative 1. This should be 0. That should be 1 because of my graph. This, not defined. This one is 0, and this is not defined. Now my signs. To this side of negative 1, notice my derivative is below, so that should be negative. Between negative 1 and 0, it's below, so that should be negative. That one should be positive, and that should be positive. So when I click on these, my calculator's going to go again, but that's alright. That's negative. Okay. So the curve is increasing on the intervals from, now increasing means I'm looking for plus. So from 0 to 1, and then 1 to infinity. I can't include 1 because it's not defined there. It's decreasing. This means I'm looking for my negatives. Negative infinity to negative 1 and negative 1 to 0. There it is. So these are 3 different examples. I hope they help. Keep working with those problems. Talk to you later. Bye-bye.